Okay, so this problem is where you put all your answers in a grid. Hopefully there's enough space on this screen to write everything I need to write. First I'm going to mention that we have these reciprocal pairings. These guys, sine and cosecant, are reciprocal pairs. And cosecant and secant are reciprocal pairs, and tangent is cotangent are reciprocal pairs. And I may give you this exact problem on the exam, or I may change the degrees and the radians around, who knows. Okay, but in this case, degrees and radians, you should know 45 degrees is pi over 4 radians. That you should have memorized. But you can figure it out if you want. So anytime you want to convert between degrees and radians, multiply by 180, divide by pi, or multiply by pi, divide by 180, whichever direction you're going. Okay, so from degrees to radians, I'd multiply by pi over 180. Okay, so I will go and get pi over 3 for this answer. 90 degrees is pi over 2, you should know that. You might start to get fuzzy further on. Okay, so let's say you don't know 2 pi over 3, you want to get rid of that pi, so multiply by 180, and then you figure out that that's going to be 120. Okay, that scratch work is gone. You leave your scratch work on. I'm erasing it because I need the space. Same technique, this becomes 405. Whoops, 405 is equal to 45 degrees because I can just subtract 360. That was kind of a trick question. And 300 times pi over 180, you're going to get 5 pi over 3. And so that's a little tricky because all these ones up above were straightforward. It's kind of easy to go from pi back to degrees. But what's happening is, again, 300 times pi over 180. You're not going to get rid of the pi, but what you want to do is reduce the fraction. You see that you have a 3 in each one, so you're saying, oh, okay, 100 over 60. You think, well, I can reduce that some more. I have 20s hanging out. Okay, so you kind of have to do that by hand, or if you have a calculator that does fractions for you, you can put in 300 and then fraction 180, and out should come 5 over 3. If you want to learn how to use that feature on your calculator, come to office hours, and I'll try to figure it out. The Texas Instruments I know how to do, but the Casios and the other ones, they also do it too. Alright, so let's see. So 45 degrees is our reference angle for this guy. And so we have 1 square root of 2 for our triangle. Here's our angle down here. 1 is y, 1 is also equal to x. That makes it easy. R is 2. Sine is y over r. So it's 1 over root 2. Cosine is x over r. Tangent is excuse me, y over x, cotangent is y over x, and then, you can figure them out either from the definitions or by stacking the other ratios once you find them. Keep your reference angles there. Again, I'm just erasing so I can draw for you. Now, if I have an equilateral triangle, I'm going to split it this way, and this is my 60-degree angle. So this part of the picture I'm not looking at. But I don't know what this leg is, but I know that the radius is the size of the triangle will be in a 2-to-1 ratio, or 1 to 1/2, or 10 to 5, whatever. I don't care what you make it, but 2 to 1 is typical. Then you use the Pythagorean theorem to find the missing side. It's square root of 3. We've done this before, but if you don't know, you'd get like 1 plus whatever it is squared equals 4, q squared equals 3, and then you'd say, oh yeah, q is square root of 3. Okay, fine. So you should be able to figure that out. And then we put all these guys in. Y over r, x over r, and then sine over cosine, reciprocal of that, reciprocal, reciprocal. It's very easy, as long as there's no zeros or infinities. The reciprocal thing is easy to calculate. Until now. Okay, so the 90-degree one, it's easier to go back to your actual graph. Here's sine, and here's cosine. There you go. Where is 90 degrees? Well, 180 is in the middle, so 90 is halfway to the middle. Sine is 1, cosine is 0. Okay, that's all we needed for that. What's 1 divided by 0? Whoops. 1 over 0 equals infinity. So if you put 1 over 0 in this table, you get no credit. If you put 0 over 1 over here, that's totally fine, right? Because 0 over 1 is just 0. And then the reciprocal of 0 is 1 over 0, and that's going to be infinity again. And reciprocal of 1 is just 1. No problem. Alright, so here's an angle where you're not in quadrant 1. That's 120. So let's see what's happening here. We did this kind of thing earlier, where 120 means how far over from the positive part of the x-axis. And so we have 60 degrees left over here with which to make our reference angle. Okay? And again, this is half of an equilateral triangle, so it's kind of hard to imagine, but this is a stretched equilateral triangle. You have to use your imagination, because it's really a 45, 45, 90, right? But let's pretend that that's an equilateral triangle, in which case you have a 2-1 ratio between those two sides. We just calculated this. We know that's square root of 3 over here. And then the x is negative. So we can go ahead and label that. And triangles don't have negative sides, but x is negative for this example. Okay, so sine is y over r, no sweat. Cosine is x over r, no sweat. Tan is sine over cosine, no biggie. And then we want the reciprocal for this guy. And reciprocal of negative 1/2 is negative 2. And then the last reciprocal, again, no sweat. Remember, when you take the reciprocal, the SIGN stays the same. It's not like you're trying to find orthogonal slopes here. You're just doing a reciprocal, no negative reciprocals. Okay, so do not flip the signs. Reciprocal is just the reciprocal. Alright, now this 405 degrees, that's easy. You just have to copy everything from your 45 degree question, because we actually just did that. If we didn't, then we would. We would, if we didn't have another example of 45 degrees. That's when we figured that out. Okay, and we've got one more that we have to think about. That's 300, and that's not in quadrant 1, so we got to think a little bit about that. 300 is all but 60. So that means 60 is the amount of angle that's coming back here. And then again we have 2(1√3) going on, but the negative 1 and the negative root 3. So, oh, sorry, positive 1 and negative root 3, because we are actually in quadrant 4. Alright, so we go ahead and figure out all our ratios. Alright, sine is y over r. And you get x over r. La-di-da. Sine over cosine. Reciprocal of sine over cosine. Reciprocal of cosine. And reciprocal of sine. And you are good to go. And it's a lot of writing, but it isn't really that hard.